my button go? There we go. So this one's called my unit circle. Okay, so circle, what is that? Well, I hear that a perfect circle doesn't exist, but you know what? This is my world, so I'm going to pretend like there is, and this is a perfect circle. All right. Now, this perfect circle is in my universe. Yeah. And well, since the universe is infinite in all directions, there is no center, but that's the universe. But what is the universe? I don't know anything about that. I know about my universe, right? And in my universe, light travels to me. Sound travels to me. Neutrons bring information to me. And if it's not bringing anything to me, then it's not in my universe and I don't know about it. And should I assume anything else exists? So for my universe, I'm the center of it. And if I'm going to have a perfect circle in my universe, I think I'll put myself right here in the middle of it. That's where I'll put me. And if I think, therefore I am, and I'm going to use that fact to say from where I am, I can either look that way or this way. When I say look that way, I'm actually saying let things come to me from that direction because I don't do anything. I just hit her passively as the universe comes to me. So I got forward, backward, up and down, whatever. Let's say this is forward. So the moment I'm born into my universe, I'm pointing, facing that direction. Cool. And I got my left and my right and backwards. All right, and then there's this circle. Well, how far away is this circle? It's the same distance in every direction. Well, I don't know of any kings or queens or rulers or anything, so in my universe, this is the only thing that exists. So I'm going to make my very first ruler ever. I'm going to call this a distance of 1. 1 radius. That's my favorite distance. It's the only distance. 1. That's 1. And since it's the only unit I've ever measured, I'm not even going to say like meters or anything like that. It's like I don't need to differentiate. I don't have different units. That's just 1. One of those. It's 1 radius of circle in this universe. Okay, cool. Well, that's nice to know. And in my universe, I can move around. I could go that way or this way or that. I could go any which way I wanted to. And if I want to talk about which way I go, how would I do that? Well, if I go forward or up or down, let's see, I could say, if I go over here, where did I go? Well, if I go over there, I could talk to the past me. I could be like, hey, you, past me, right? Where am I now? Well, compared to where I was, there's a difference. The difference is I didn't go up or, wait, I did go to the right 1 radius, and I didn't go up or down. I could do that. Or instead, if I stayed here, instead of going forward, I could go backward. And if I went backward, I'd say, well, I went backwards 1 unit of circle radius, but I didn't go up or down. But if I went up or down, I would say I went up 1 unit. Wait, I did it wrong again. I didn't go right or left, but I went up and down, and that might be information that I could use later on to find my way back, because I don't want to, forget where I used to be. And if I came down here, I'd say, well, I didn't go to the right or left, but I went down 1 radius of circle. Cool. That's a great way to do it. But what if I wanted to go over here? Well, I know that's a distance of 1, but if I wanted to tell myself how to get back to where I was, how would I tell myself how to get back to where I was? Because this is where I built my little house. This is where I live, and I like my little house. And how do I get back? Well, I need to be able to tell myself where I am. Well, these were easy, up, down, left, and right. Those are my directions. So if I'm going to get here, I could do this instead. And I could say, well, I walk this far and then this far, and that's what I'll put here, my left and right and my up and down. Yay. But wait, I don't know how far that is. Well, okay. Maybe I could figure it out by thinking. All right. Come on, iPad. How do I fix you? There we go. Okay, so thinking, I'm not going to do any kind of thing dangerous here. I'm going to keep it simple. I'm going to walk a distance, and then I'm going to walk the exact same number of steps that way. So I'm going to go this way, and then I'm going to go up, and I'm going to make sure that however many steps I take this way, I'm going to make the same steps that way. Okay, so I'm here. That's my new spot. How do I get back home? Well, I could do this, or I could do this. Well, I still don't know where this is. I know how to get there. I know how to get there. The way I got there was like this, because I didn't want to get lost. And I know I can get back. But I want to have an address here. So how many is this compared to my ruler here? I counted steps, but what is the address compared to this one unit, that real ruler I have? So maybe I could figure it out. This up and down, left and right, I don't know about it. It's kind of tedious, right? I don't want to do this. I want to be able to go straight there. It'd be so much quicker. Well, how do I describe that direction instead of left, right, up, and down? Well, there's this thing called angles. I'm going to use this little symbol to represent it. We'll call it theta. That's going to be this angle. So instead of saying this way and that way the same amount, and it doesn't matter the amount, I could go this, as if this is the same amount, it's still the same direction. I want to talk about direction, not location. So this kind of tells me about direction. Maybe that direction will be useful in talking about location. Okay, well, this I'm going to call 45 degrees, just because I really like 360, and half of 360 is 180, half of 180 is 90, and half of 90 is 45. Just because 360 is so cool. Okay, awesomeness. Now, how do I figure out that address? Well, if I know these lengths, I didn't have to go this way. I could have gone the same amount and the same amount that way. Could have done that, or I could have done the same trick this way, or I could have done the same trick this way and not got lost, because that's my only trick right now, is walk the same direction or the same distance in one direction and then hang a 90-degree angle. So, how do I figure this out? That's my only trick. And now I could go that way, that way, that way, that way, and I could go where I am, but I still have to figure this out. Well, let's zoom in on this guy, because it's the same problem no matter which of these four directions I go. So let's just look at that guy right there. If that is specifically, not that one, 45 degrees. So I'm gonna replace you with 45 degrees. Boop. Okay. That's the same. But wait, there's this old dude who stole this idea that said, whatever this side is squared, okay, if I make a square, the area of this square is the length of that side, and the length of this side squared, well, here's the square, so this square and that square, they said, was the length of this side. squared. Okay. So if this is, I'll call that just ABC because I just like those letters. A squared and B squared is C squared. This area and that area is the same as that. Well, how does that help me? Oh, wait. These are the same length. This square is the same as that square. Oh, so really I could have just called this A. So what I have here is twice A, right? So A squared, that's what that guy said. But wait, that's the same as that. So there we go. And then, okay, two of these. I'll just put that, get rid of that plus sign, turn it into multiplication. A squared and A squared, 2A squared. All right, sweet. Is C squared? Okay. Well, wait a minute. What else do I know here? Oh, wait. That is 1. Duh. This is just 1 unit of circle radius. So, yeah. But 1 squared is a 1. Okay, well then, well, if that's 1 and these are the same, all right, then, okay, A squared is 1 divided by 2. That's a half. That's a half of a square. Oh, well, here's my square. It's this much. That's what A is. No, wait. That's what A squared is. Yeah? No. A squared. This is A squared. Okay, the area of that square. It is equal to 1/2. So the area of this square is 1/2. Okay, well, what is that? 1/2 is a number that's an area. Well, how do I make a square whose area is a half? If the area is a half, what is the length of the side? If the area is a half, and that's my square, the area, well, let's see. That means that A would have to be the square root of that. Okay. Because this times this makes that square root go away, because the square root is just a fancy way of saying the length of the side of the square if the area is a half. Okay, so A, the length of the side of the square is this. But that's just the same as this, because that bar is just kind of in the way. And I know that if the area of a square is 1, then the side has to be 1. This is really 1. Yay! So now I know this triangle, boop, 45, that's a 1. This has to be 1 over root 2. That's what we'll call it in this universe. And you know what? I also know that 90 and 45 add up to, what, 135? I know that these have to add up to 180. So 90 and 90 would work. So this one has to be the same. Because the lengths of the sides are the same, the angles are the, all right, here we go, we're getting there. Cool, so that tells me if I go to the right and I go up the same amount and I hit my circle, I have gone a distance this much. That's the distance. Okay. Now, this is the name of a number of a quantity, but how much that quantity is, I don't actually care. It's in units of circle radiuses, so whatever. That's the name of it. But you know what? Some people don't like it like that. They're not in my universe, but if I went to somebody else's universe, they would want me to do this. Multiply, well, if these are equal, I can either add 0 or multiply by 1, and that's it. They're going to make me multiply by 1, but they're going to make me do it a smart way, because they don't like this root symbol on the bottom of the doodad. Okay, fine. That times 1 is that, and that'll make the root symbol go. So some people like it better like that. Root 2 over 2 instead of like this. They are the same in value. I like this way better, honestly. Where's my colors? Give me colors. Give me colors. There it is. I like that better. It takes fewer pen strokes, less effort. But other people Oops. That's, they want you to write it like this. And so just to make the rest of the mini universes, the multiverse happy, we're going to write it like that. These are equal. They're the same value. Mathematicians do this. Physicists and engineers probably do that, but they're the same thing. Okay? Cool. Well, I know the length of the sides of that's the same triangle everywhere I go. But over here, since I went to the left, and I mean backwards and up, I went backwards and then up. And over here, I went backwards and down. Okay, here's backwards and then down. That's what that little minus sign is for. And over here, I went to the right and then down. It's all the same number. We should have just called it something else. Oh, we could totally do that. How about we give that quantity an easier name? I don't want to use A, B, C, but maybe in class we could think about different name, because this is like, you know, Gemini, Himini, Barbara Jimenez. Can we come up with a nickname like P? P? No, we don't want PQR because this is the radius. We'll use R for that. You know, they should have a symbol for this that's not a collection of twos and bars and radicals. Yeah, we'll do that. Okay, but those are all the same, but a minus sign to give us direction. That's my universe. Now I can go over here. I have an address. I know how to get back, right? I go down that far and left. Okay, but I like my angles. If that's 45 degrees, what direction is this? Well, 45 and 45 is 90. 45, 45, and 45 is 135. 45, 45, 45 is 180. So 90 and 45, 135. Man, that's a big O number. Okay, so what about that way? Well, 180 and another 45, that's what, 225. That's cool. And all the way around here, no, I'm not going to do that. All the way around would be 360. I'm 45 short of 360. I'm going to think about it like that. That's better. 360 minus 45 is, what, 315. That's my new name for that direction. Okay, change my color. Yeah, come here. Okay. That direction is called 315 degrees. This direction is called 225 degrees. That direction is called 135 degrees. That direction is called 45 degrees. And these little locations on my on my perfect circle, I'm going to give them these addresses because that's how far I go, up and down or back and up. And it's the same distance. Sweet. Well, it is interesting that 0 and 45 plus 45 is 90 plus 45 plus 45 plus... All I did was kind of take my circle and break it into pieces of pizza. They're all the same size. I got 1, 2, 3, 4, 5, 6, 7, 8 pieces of pizza in my universe. And they're all the same size. That's sweet. What else can I do? Well, here's my universe. Well, there's me. This is my universe. There's my perfect circle. Okay, so instead of going that way or that way or that way or that way, by my little trick of going the same distance, what if I did another trick? What if I want to go that way? Instead of at 45, we're going to call it 30 degrees. Ooh. Well, whatever trick I use to figure out what that address is, the left, right, up, and down address, I could use that same trick to go this way, or this way. Yeah. Because if I figure out the trick to know what those links are, I could do that. I could apply the trick here, here, here. Oh, but wait. Check it out. If this is 1 unit of radius, This is 30 degrees, and I know this is 90 degrees. 90 plus 30 is 120, which means this would have to be 60. And now if I give this the name A and B, because for some unknown reason they're the first letters of the alphabet, easy to reach, how do I figure out these links? Because if I do, I could use the knowledge of these links to not just go in these directions and find my way back. Check it out. I could go in that direction. That's 60 degrees. Look at that. So that little triangle there, boop, 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 that's that triangle there. I could put it like that instead and use this 60 degree here. This is 60 degrees direction. And I could put it over here too. And I could put it here and here, the same thingy, that same guy. So I not only get the 30 and the 60, but wait, hold on a second. 30 plus 30 is 60, plus 30 is 90, plus 30 is 120, plus 30 is 150, and plus 30 is 180, and plus 30 is 210, and then plus 30 is 240, and then plus 30 is 270, and plus 30 is 300, and plus 30 is 330, and then plus 30 is 360 degrees, which is the same as 0. So this is really just all the multiples of 30. Those are my directions. Oh wait, the last time was all multiples of 45. 0, 45, plus 45, plus 45, plus 45, plus 45. So it's just 45 degree direction turning. Or here, it's 30. 30 plus 30 plus 30 plus 30. I could rotate by 30 degrees instead of 45 degrees, and I could do it over and over again. And if I just figure out those links, I would know the address to every one of these points. Well, let's figure it out. I know by that old guy who stole the idea that a squared plus b squared, in this case, is 1 squared, which is just 1. So, But these aren't the same like last time. They're different. But you know what? I got this trick. I can pretend there is a copy of the same triangle there. And if I do that, then I know it's an identical triangle. Ooh. Okay. This triangle, this is the same as those. And if this angle is the same as that, is the same as that, that means all the sides are equal. And since I know the length of this side, I know the length of this side is 1, which means the length of this side is 1. And if this is B and this is B, then 2 B's is the same as 1, which means B has to be a half. Woo! So I'll put a half right here. Boop. Yay! So 1/2 squared, well, 1 squared is just 1. And then 2 squared is 4. And over here, 1 squared is just 1, right? Okay, great. So let's take this 4th and shove it over there. 1 minus a 4th is 3/4. So to get rid of that little guy, I'm like, go away, go away. It does that, and what is that? The square root of 3 is that. And the square root of 4 is also known as 2. Ooh, I got my A, and I got my B. So awesome. So here's the 30 degrees, and this is 1, and this is 1/2, and this is root 3 over 2, and this is 60 degrees. And over here I had that first triangle, my 45, 45, and 45. And this is 1, and I learned that this is root 2 over 2, which could also be called 1 over root 2. So in my universe, I can now go in any direction and know my location. Any multiple of 30, 30, 60, 90, 120, this way, add 30, add 30, add 30, add 30, add 30, add 30, and I know the coordinates, because it's always this same triangle, this guy. I could put it here, or I could put it here, or I could put it here, same triangle, or I could put that triangle here, boop, or I could put it 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 over here, boop. There's a big side and a little side. So I got a big number and a little number. So for all of these, all I have to do is put the minus sign. And well, for this guy, I could just, instead of the big number first and then the little number, it's the little number first and then the big number. But the same two numbers, right? Since that's the little number, we got up a little bit, but to the right more. Same two numbers all the way around, all the multiples of 30. Cool. And what about this one? Oh, the multiples of 45. All right, well, if those are multiples of 30, remember, this is a perfect circle. Just pretend, okay? 0 45s, 1 45. 45 of 45 is 90. 45 that way, add 45, add 45, add 45, add 45. And I know my addresses for all of these points on my perfect circle because I know the lengths of the sides of this triangle. Both sides have the same length. Same triangle, same triangle, same triangle. Since I know this is root 2 over 2, these guys are all root 2 over 2. Root 2 over 2. Root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2. Just put the minuses where they go. Now I can go in so many directions. It's really just multiples of 30 and 45. But there's an infinite number of other ones. I wonder if I could find out more. Maybe later. But these symbols, these names are so long. We got this, and then we got this, and then we got this. And I know that there was a big side and a little side, and then there was the one with both sides were medium. So which of these numbers is the big one, which is the little one, and which is the little piggy in between? I'm comparing them. Well, let's just forget about that by the rule of samesies. We'll look at these. Well, I still don't know, man. They look all complicated, but I do know that this is the same as that. And so by the rule of samesies, let's forget about those. So which one's the biggest? 1, 2, or 3? That one is. So that's the big side. Which one's the littlest? That one is. So that's the little side. And the one in between is that one, which we called this. And you know what? I'm tired of writing all this. We should come up with our own symbols for these lengths. They should have their own names instead of root 2 over 2, which I could also call 1 over root 2. Let's come up with a different name. This symbol's archaic, right? Yeah. Come up with our own symbols. Now, this is already taken. The next easiest thing is that. And really all the letters of the alphabet. And the Greek letters and the Latin letters. I don't know. That's an interesting problem here. We need new names, new symbols for these sides. That would make it real easy to like write this stuff down. But you know what? These degrees things, somebody said they don't like 360, and you know what? I don't either, because on one hand, I only have this many fingers. The same over here. And I don't really like this either, because what is that? That's really 3 times 10 squared plus 3 times 10 plus the, what is this? Yeah, that's what that really is. There we go. Is that right? 3 times, no, 6 times 10. That's what that really means, because this is not 360. This is 360. So it's really 6 humans worth of fingers, and then if you take 10 groups of humans, 10 groups of 10 humans, take their fingers, and take 3 of those, that's how many this really means. That sucks. And what is even that? Degrees. Like it's a temperature? No. We need something else for measuring an angle. And instead of this, what's relevant here? Here is my circle. here is 1. That's my number. That is my distance. That is my measure. And, well, that's when I don't turn at all, because when I was born into this universe, I was facing that way. And so I'm measuring how much I'm rotating. Okay, and well, that's also 1. So the only other thing here that's a length is this. And maybe I'll use the letter S for that. We'll call it, this is like an arc over my head, but it's over there. I'll call it a length, but it's an arc. I'll call it an arc length. So the more I rotate, the bigger that arc length is. So I'll just make that my angle. Whatever that number is, that's my angle. Now, if I had a bigger circle, instead of just taking that, I could do the ratio of this to the radius. But here, since the radius is just 1, so I'll call whatever angle I have, I'm going to call its measure the ratio of that arc length to the radius. And for me, in my universe, since I called this 1 unit, for me on the unit circle, my unit circle, it's just the ratio of S to 1, so I'm just going to call it S. And since this is 1 unit circle radius, those are my units, I'm just going to call it 1. Then whatever length this is, that's what my angle is going to be. So if this was like a half, then my angle would be a half. But a half is just, I need to know that I'm talking about an angle when I just say a half. So I'll call them radians. Yeah, because they're rad, right? So this is going to be the measure of my angle in radians instead of these silly degrees. So wait a minute. If all the way around is 360 degrees, and all the way around in radians is the same as the length of the arc, and I know from some old guy that the circumference of a circle is 2 pi times the radius, but here the radius is just 1, and the arc length is the same as the angle. That makes that radians. Okay, so 360 degrees is the same as 2 pi radians. And I get tired of writing radians, so I may or may not write it. So if you just give me a number, it's a number, but if I want to take it as an angle, we'll call it radians. But since it's a ratio of a length to a length, it really is just a number. It's called a dimensionless unit. There you go. Divide them both by 2. Boop. Divide them both by 2. Boop. Okay, divide them both by 2. Boop. Okay, that's cool. These are all the multiples of 45, right? All right. Well, instead of that, my other favorite ones were multiples of 30. Okay, so instead of dividing by 2, what if we divide by 3? How many times does 3 go into 3? 38, 9, 1, 2, 100. If I divide this by 3, I get 120 degrees. Divide that by 3. Okay, cool. Oh, this is interesting. Huh. Or I could have done it from here. If I divide that by 3, 180 divided by 3, well, that's 60. And then divide that by here. That would be the same as pi over 3. Or I could have divided this by 3. 90 divided by 3 is this. That divided by 3 is this. So 30 degrees is pi over 6. All right, so what do I got here? I got pi over 6, that's my 30. And pi over 6, that's 1 pi over 6, 2 pi's over 6, 3 pi's over 6, 4 pi's over 6, 5 pi's over 6, 6 pi's over 6, which is just pi. Of course, this is just pi over 3, right? This was 3 pi over 6, which is the same as just pi over 2. Just, okay, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi's over 6. Or I could have done the 45s, which was pi over 4. 0 pi over 4, 1 pi over 4, 2 pi over 4. Well, that's the same as pi over 2. 2 pi over 4, 3 pi over 4, 4 pi over 4, 4 pi over 4 is the same as pi. 5 pi over 4, 6 pi over 4, 7 pi over 4. then I can use these because I like 7 because I have that many fingers. I don't like 300 and something or another. That's a horrible number of fingers. I don't even know enough people to have that many fingers. And this guy's cool. He's just like, hey, you like my hat? I represent a known number of fingers. And it happens to be whatever the distance is from here to here. I read, if they're going to use that to represent that distance, let's come up with our own symbols to represent these 3 distances. The lengths to the sides of those 2 triangles. I want my own symbols. I'm so tired of writing that. It takes forever, right? We could have done like doodle doodle doo with a cool hat, like that. That could be this, or something more fun. I don't know. Let's play with it, y'all.